So good morning. First of all, thanks to the organizer to invite me to give this talk. My name is Calvanese. I work in CADT. I'm the Smart Device Telecommunication Strategy Program Director. The title of this talk is 5G and IoT, Opportunities and Challenges. So first of all, when we speak about Internet of Things, we have many things in our brain. So we have different visions of what we're speaking about, depends on what we work for. People work on sensors, have problems about material, energy, about communication part, about the security, the privacy, the computing, the internet working of sensors, and so on. So if you look to if you just Google a little bit the Internet of Things, you find different angles to approach this problem. So you have a dynamic global network infrastructure of adaptable, interoperable devices. So here the real point is about the dynamic of the system, because actually we have system with a lot of different density of users and sensors in the system, but also you have to adapt and also have to have some way for which different sensors can work together. Then also you have another view which is more focusing on the collection of technology, where actually you allow the physical world to be accessed through the software. So the point is that sensors are your step in the real world in order to manage that from a virtual point of view. Then you have also the point of view of the digital connectivity on top of existing infrastructure and things. One on the other view is more about the application itself. So this networking of devices and application in order to create business. There's also some generic view like interconnecting anything, anywhere, anyone, any place, any service, any network. So the things that roughly the IoT does everything. So this will be the solution for everything. And then a world where the real, the digital, and the virtual are converging to create a smart environment. This is more the vision of what they call cyberphysical systems, which is one of the major trends, actually, I believe, personally. Also, people call that the real world web, because actually it's the extension of the web to the physical world. So which is the major goal of the IoT? IoT in global, so if we're not looking to our problem as a researcher or of, for example, delivering that specific sensor, that specific power harvesting and so on, but the overall thing, it's more on giving smart environment, smart application, and self-aware sensors. So we are creating ecosystems in which we mix physical entities with a kind of virtualized context and a remote control intelligence. So to do that, we do that for creating a smart planet in which we have different kind of specific challenges, like, for example, doing environment sensing, doing pollution or weather monitoring, water monitoring, and so on. We have the context of smart buildings in which, for example, we consider more the health of the infrastructure we have. We consider how we manage energy for example, thermal energy for the heating and so on. Smart industry, there's a very huge trend today with what we call the factory of the future, in which actually we do a lot of automation, control by sensors, and then we actuate given kind of strict deterministic procedures. Now we have the smart health and leisure, where actually we apply this knowledge to human being in order to detect problems or empower human beings to some specific context. Smart living, that's more on the leisure part as well, about entertainment, about leisure, and so on. Smart transport, well, we'll go back to that later, on what we call the Internet of Transport, because actually we apply all this smart environment in order to coordinate transports and energy related to transport. And the smart energy, which I talked before already, give a lot of points. So the idea is really to manage in a smart way the energy, matching offer and demand in the location and time scale. So all this wish and all this hype around IoT gives actually specific challenges that we have to face in our scientific work. Like one is the energy efficiency, where, for example, we work on power grid, we connect electric vehicles, and we do energy efficient building, and so on. Then there's also the problem about environmental protection, where we want to deliver green services. We want to design specific sensors that have markers that make sense on a specific environment and can also be ecologically sustainable. Public health and also sustain to aging population. One of the common new trend is also about, for example, the matching of generation. There is a one of the things we do with the IoT now, it's, for example, to do what they call the serious gaming. That means we create context of gaming in order to teach people how to behave. And actually, for example, in changing the generation at work, generation that are now on the 50, 60, they are close to retire, are teaching to new generation how to improve their knowledge on specific work. And then we do today also assisted by IoT devices in order to generate a fake environment where we enforce and stress some specific problems. Safety and security and privacy, this is a huge problem. Safety can be seen from two different points of view. Safety of the individuals or the population, but also safety from the point of view of that what we want to deliver is what we deliver, does not attack on the digital system. Privacy, it's more related to the huge amount of data we are generating, we are collecting from people, and how this data can be anonymous from the point of view of the single user or the community itself. And then there's another point that's very interesting, that's quite new trend since 2-3 years, I would say, is the societal awareness. That means actually the social IoT, where we have user awareness, we do the web of people, we are interconnecting people from the point of view of the devices they have on their self. And actually we gain information about what they know, what they do, and we also do prediction of what they can do. So I was saying before, all this approach need a cyber-physical system where we do the interconnection between a physical world where we have the measure we want to measure, we have the sensors we use for the measure, and an IoT system that interconnect different pieces of our IoT system. And then we have another layer, which is the service. So the service want to be as generic as possible. So want to ask for semantic questions. Then actually the IoT system translate on a specific context-aware demand of triggering measurement and control on the physical world. So IoT has several related challenges. The first of all, from a point of view, is really make sense out of it. Today, again, is a hype. IoT is a hype, and so we want to do IoT in all the different dimensions. But what we do with all this massive data, how we do the mining of this data, how we do the efficient calibration between different heterogeneous systems we are using. Another question is about the deployment, where we place the sensors, how many sensors we place, when we trigger the activation of the sensors, how we do the maintenance of the sensors, and most of that, how we manage the scalability of the sensors. It means actually sometimes we only need in this room one sensor, so there was an example before. Sometimes we might need maybe 300,000 sensors, depending on what we do. How we manage the coexistence of such large dynamics. And then the energy. We were speaking about that quite a lot today. The low energy, the energy harvesting, the energy saving, and the low power communication. Another perspective is more about so we have all the sensors, so we do the physical measurement on the real world, but then we need an intelligence that tells us if we have to do some actuation, what we do. So we need to do some computing. Do we do the computing locally? Do we do the computing in the cloud? Actually, one of the trends today is speaking about the fog cloud. So that means actually it's very distributed cloud, very close to the sensor, where actually we reduce a lot the energy for the communication needed, but also the delay between the moment we transmit, we compute, and we give the feedback. So depending about the application we need, actually there is there's a huge concern today on understanding which kind of architecture we do. We do strictly local, we do centralized, or how we do the hybrid. Then another point is also incorporating the human in the loop. So more and more, the IoT is interacting with the user. So how we represent, how we forecast the behavior of the user, and how we also empower the user awareness given the IoT. Another point is to have a reliable network and a self-healing network. And another point is to be, as was the third talk actually about, to be real-time. Real-time means all or nothing, because actually real-time means understanding which is the right time scale we want to use for. So actually, how to dimension the system for what we need, how to adapt that. Then there's one of the problem that from a point of view can be really a bottleneck in the future is the security and the privacy. Today, everybody's open-minded to give our data for trading our data for a service. In the future, it might be that actually either we find a real privacy solution or we'll stop using this kind of technology. We'll go back to our farms, our mountains, just to be isolated to technology. And then the last point is about standardization. There was a question this morning about standardization actually depends on what we're speaking about. So if we stay local for the communication point of view, we don't need standards. We can treat it locally. But if we start interacting between islands of sensors doing different things, actually we need a standard in order to understand each other, how we communicate, how we exchange. One of the ways to solve this problem today is the 5G, fifth generation telecommunication standard, where actually we target to provide a common ground for using different local standards and integrate together. So we speak about the novel Internet of, which is not only things, but we can be more specific. And actually, that's for optimizing, for adapting, for securing, for advice, and for control, and actuate in a given physical system. So we speak about, for example, the Internet of Energy. We can do the Internet of everything from this perspective. We can do also the Internet of students. Okay, I just giving some examples, but actually the Internet of Energy, the idea is that instead of in the communication system, you have a packet, you have a gateway, you have a router, and then actually you have to convey packets given kind of constraint, quality of service, quality of experience. You have to send these packets. It's the same thing from the point of view of the energy. We are doing with the same approach. We have energy packets that autonomously should find their path through the grid in order to go to A to B in a given time frame, and so on. So the approach is actually how we can exploit kind of sensing, control, and actuation in order to optimize offer and demand in the local context in order to reduce the overall consumption or overall energy needed. Then there's the Internet of Vehicles. Same approach. What we do, we interconnect the smart infrastructure, roads equipped by sensors, satellites that communicate over a large zone, and so on. The sea as well, you know, with some specific sensor, floating sensors, and so on. And actually, we interconnect this infrastructure with vehicles, trees and vehicles, and so on. So actually, the idea is that we want to, for example, decrease the pollution caused by transport, that the time spent in transportation with the traffic, the time or the cost related to logistics, and so on. So we interconnect all the things together, and we create what they call the Internet of Vehicles, an Internet of things. Yeah. Then there's another thing. It's about the Internet of Water. It's another example. Today, it's about 5 years. We seriously start working on monitoring water quality, detecting leakages of water, matching specific contextual demand of water and specific capacity of deliver the water in that way that actually we can really optimize all the system. Of course, that needs a lot of OPEX and CAPEX investment for equipping with sensored infrastructure. Sensor can be statical or either flooding sensor that can go through the network, this new network, which is the water network. And then we can have an instantaneous indicator about the specific leakages, say the pressure, the amount of demand in one area and the other. And then we do all things we already know in other kind of domain, load balancing of water, all the things. So that's really, we bring intelligence in a context which was very old-fashioned context. A wonderful example of mixing different Internet of energy, transport, and so on are the smart cities. These are contexts where we mix all the things for the common task of empowering the citizen living a better life in the city. And actually, we have several challenges here, which is the one I said before, but the other thing is also the coexistence of different needs on the same specific area. This picture takes from one of the cities that's really employing impressive deployment of sensors. I guess it's about 100,000 today sensors in the city. This is Santander City. We're actually, since 2009, they've been working on creating this smart environment. So now, 5G networks. 5G network, the 5th generation of telecommunication networks. So now today we just start using the 4G networks. Our view as an excellent opportunity for interconnecting the Internet of Things. The point is that actually the real claim for having a new generation network is not about interconnecting humans with their telephone, but it's really interconnecting the large amount of devices we're going to face in the future. I will be more specific in the next slides. So which are the challenges? First challenge for the 5G is for sure the huge traffic volume. We foresee in the next 10 years more than factor 1,000. So you can think about the throughput we have to deliver, the bandwidth we need, the new spectrum, and so on. But the other part, it's about the massive growth of connected devices. Most of the time also are not coordinated, so we do not exactly where they are, how they interconnect to each other, and so on. We speak about an order of at least 50 billion of devices in 2020. And then there's another point that is really related with the Internet of X in general, is the large diversity of use cases and requirements. With IoT, what we do, actually we have an application, we create exactly specific use cases, requirements, and specific traffic partners. So actually we have different optimization requirements in the network. How to deal with that? So this kind of slide was already presented in the talk before. What I want to point out, actually, we used to live in a world where actually there was the worldwide population was much more larger than the technology we were communicating with. So in 2003, for example, there was a lot, where I don't remember exactly, 6 billion people in the world. It actually was just a small amount of connected objects. Then in 2010, still, in 2010, we already faced the inversion, actually having much more connected objects than the worldwide population. And the view is that in 2020, the population itself is not significant according to the number of connected devices. That, of course, not because, users, people will have maybe 1, 2, 10 sensors, but we are equipping everything. We're going to be the roads, the water, animals, and so on. So the connection is everywhere. And then that gives opportunity from the business point of view. You have smart homes, intelligent transport, business environment, and so on. So we can apply all distributed intelligence in kind of places. Then, if you look to the 5G telecommunication system, they have different target scenarios, which are the fast connectivity, which actually is not really something concerning the IoT. Then actually the grid service in the crowd, this is the case, because it might be that we have a stadium and so on, a lot of devices there, and how we manage a huge density of devices in the same physical area. Best experience follow you, it's more about mobility. I would say that when we speak about mobility in IoT, it's not the same degree of mobility we speak with classical cellular networks, because actually it's not that speedy. Super real time, again, this is not maybe the major concern, but the ubiquitous things communicating, that is really the major concern we have in conjunction between 5G and IoT. So which are the 5G technical objectives? Having indeed a factor 1,000 more data volume in the network that we can treat. Then have between 10 to 100 times more devices in the network. And okay, throughput is not maybe the major concern in IoT, but actually, if you go to the battery life of devices, we ask for a factor of 10 in energy consumption reduction. So if you look the evolution for 4G to 5G of requirement, technical requirements, so we see the latency, the peak data rate, cell average data rate, cell spectral efficiency, mobility, energy and cost efficiency, and simultaneous connection. So we have in 4G, we cover this space. Without going into all the numbers and details. Now we will ask for 5G. And where it's really impressive is the improvement in number in terms of simultaneous connections. So here it's really the problem from a point of view in the future IoT, having so many devices connected on the same physical area. So here you have some numbers, but what it's worth again is see the devices per area. We target in 2020 have about 300,000 devices per access node, up to. Okay, this is just a short slide to give you an idea about the readiness of technology of 5G. 5G will be ready, I said, about 2020, and that time we should be ready to deliver the standard needed for interconnecting different islands of sensors, of IoT sensors. So if I want to conclude, first point, it's how to make sense, making sense out of it. So how we create the knowledge and make it available. How to process this massive amount of data and for this paramount of heterogeneous applications. So that requires as well this local cloud paradigm. One of the major issues if you want to optimize the IoT system actually is the variability and the diverse and heterogeneity of the application space in IoT. So we have specific traffic with the specific application needs. We have different virtualization of the physical system, and then we also have different way of dynamically exploit different specific objects in the environment. We also have the problem of creating a community wisdom. So how to include IoT equipment human in the loop, and how it's not only from a technical point of view, but also how to ensure the privacy in there. We have a list with the IoT application to serve 3 different types of users. The individual citizen, us, the community of citizens, like say, for example, students or citizens and so on, given a specific core of interest, and the enterprise. Then I said before, the security and privacy will be the bottleneck of this technology. We need, as was said also before, another discussion, new energy autonomous communication. Today we're thinking about at least 1 milliwatt RF consumption per node, and also we are looking for a fully powered by nodes by energy harvesting. One of the new trends, I saw some specific case, for example, it's what I call the visible light empowered sensor, where actually we use visible light communication for transmitting, but at the same time, while modulating the light, we also recharge the battery of the sensor. So there are some nice ideas around that can bring us to zero power communication and existence of sensors. We need also not to design only one system or another, but the real question how we coexist with a different system design, the way that the same sensor can be used by different needs. And that's the reason, because you have all this software approach for APIs approach for actually trigger and actuate different sensors. And then a universal solution and a standardized solution is a hot topic today. And 5G networks are one of the best candidates for this integration of a telecom infrastructure, verticals, and smart X paradigm. So if you have any questions, that's finishing my presentation.